The next lecture is planning in artificial intelligence. So what we have seen so far is all about search. So we have defined the problem, we have knowledge, we have seen that how to define those knowledge in form of rules or graphs and feed them into the knowledge base or the database. And by using search algorithm, you can retrieve the knowledge from the knowledge base, and you can use those to achieve various goals based on the problems. And we have also seen how to represent objects in form of logic, how the artificial intelligence system can use reasoning, and it can use reasoning to come at various conclusions. And the next step is that an artificial intelligence system in a very complex functionality should also be able to have knowledge of planning. So it should, if it is given a certain task, it should be able to plan the sequence or the sub-states in which it should do the task, and it should consider the different states it will go through, and it should consider the effect of the different states that will have on the final goal it can achieve. So when there are different states that could lead to a goal, a search agent might find too many actions and too many states to consider. Heuristic functions choose only among the states and cannot eliminate action from consideration, so which action could be taken. So dealing with such situations, it is very essential that if you are planning a very high level, if you are designing a robot, or if you're designing a robot which could do 10 functions, 100 functions and 1000 functions, and in such cases it is very necessary that the agent should be able to plan when it is given 5 different functions which is interrelated, and the agent can be only at one state at a time, and it cannot be at 2 places at one time. So it should be able to plan between which state it can do, and what will happen if it will do one state, and what will the effect of doing one action on the other action, and the final goal may be or sub-functionality of multiple goals, and it should be able to choose. And such kind of knowledge can be given in the algorithms and can be brought into the system by using a planning functionality, which is essential for artificial intelligence system. Suppose if you have a robot which have multiple functionality, like it is designed for multiple tasks, like it can be programmed to go to the pet store, it can be programmed to go to the school, it can be programmed to go to the supermarket, it can be programmed to read a book, and in the supermarket it can buy a tuna fish, it can buy a milk, it can buy a bread, it can go to the school and it can go to the class, or it can buy a dog or something. Many functionalities you have added as a task to that robot or artificial intelligent agent. So if you consider an initial state of the agent is at the home, and if you are given it a task is that it has to get milk, bread and banana, and plus you can give a task of going to school. So the agent will have to be able to plan as which functionality it should do and what it should do. So if you use a search algorithm planning to do such a problem, branching can be huge and the search is inadequate. Also, the agent must consider action sequence starting from initial state. So the agent should know that before purchasing anything it will have to get to the supermarket, but the agent using a search technique does not know this. So the planning is a sequence of action that can achieve a goal. So before defining any action, there should be a sequence of action. So the impact of action A on action B and the impact of action B on action C should be considered while you are defining a goal. And such kind of problems can be solved by using a planning. So divide and conquer is one of the method. An efficient planner should consider problem decomposition. It should work on sub-goals independently. Like going to the supermarket is the first goal, and once you are going to the supermarket, then you can buy milk, you can buy banana, and you can buy bread. But if your budget is only 20, so agent should again be able to consider the budget while planning. So if you can add more such kind of functionality by using planning. So some deduction of how planning will work is using preconditions. So what we are setting is that for an action to happen there should be a precondition. So suppose in this case, for the milk to be brought, the precondition is that the agent should go to the supermarket. So if the agent is in the supermarket, it can purchase milk. So that kind of precondition you can plan using setting precondition. We know that. So some of the facts or factors that should be considered are considered while defining planning are: you must define states, you must define goals, you must define preconditions and post conditions. So we can use specification languages like scripts or ADL to describe a system and another. Possibly to describe system is planning domain definition language. It primarily describes a system using set of preconditions. So specific languages like scripts or ADL can be used to program in a way that takes the precondition into consideration. So scripts is one of the language and ADL is another language which is primarily or hugely considered while dealing with situations or programming using the planning functionality or the planning algorithms. The planning can be executed using two algorithms. One is forward state space search and the other is backward state space search. Let's look into a simple example of how preconditions can be used for planning. So we are first defining the initial state. This is for a cargo agent, which manages the loading and unloading and the scheduling of flights for cargo. So the initial state is that the cargo 1 should be loaded at San Francisco, cargo 2 should be loaded at JFK, and the plane 1 should be loaded at San Francisco and plane 2 should be loaded at JFK. So in that way you have defined the different possible initial states and preconditions. During the plane problem, what we have seen is that the initial state is that the cargo 1 has to be loaded at San Francisco and the cargo 2 has to be loaded at JFK, and at plane 1 has to be loaded at San Francisco and plane 2 has to be loaded at JFK. Again, the cargo 1, we have defined the cargo 1 as C1, cargo 2 as C2, plane as P1, plane as P2, and the airports as JFK and San Francisco. So what our goals is that to load the cargo 1 at JFK and to load the cargo 2 at San Francisco. So the action which we have to take is that load cargo in plane at airport. So the action which we need to take is that we need to load the cargo at plane at the airport. So the precondition we have defined using the at condition. So we can load the cargo at the airport provided that the plane is at the airport, and the cargo which we want to load and the plane which we want to load and the airport we want to load. So the effect is that the cargo at this airport, that is a cargo A, and the cargo will be in plane using the IN function. So that was a loading function, and again it is the unloading function. So in the airport, unload is that the cargo is in the plane and it is at the airport and we are unloading the cargo. So again, after that the action is to fly provided that the cargo is in a specific plane. So that was how you define the problem using the planning functionality. So problem can be defined with three actions, that is a load, unload and fly. The predicates means in means that cargo is in the plane, at means that the plane is at the airport, and when it is at, then the plane don't have cargo. So if you have at an airport and then you have already unloaded it and it is available to reload, so that you can load and you have flight and then you can unload, load again and you can fly. So that way, based on the precondition, if it is satisfied or not, like if the cargo is not in the plane, then you can't load it again. If it is unloaded, then you can load it again, and if the cargo is the plane is loaded and it is available at a specific airport, then you can fly to the other airport. And if it is plane 2 or plane 1, and based on those preconditions you can clearly define certain actions, like you are saving yourself from errors like flying a plane without a cargo or loading a plane which is already loaded. So such kind of errors can be avoided by having a sequence of planning. So that's all. If you like this video, please do subscribe, like and comment.